Okay.
Like it's slow.
Okay. And then fast? Okay. So here's what Brady's saying. He's talking exponential growth is slow then fast, okay? On a graph paper, Brady. Whoa, that's Y. That's X. On graph paper, what does it look like again?
What? Oh, it's like it goes parallel for most of it, and then eventually it just kind of grows almost like a curve at like 90 degrees.
Okay, so parallel to what?
The Y. Or X and then Y.
Okay, the X, and does it start here or here?
No, because that would, it goes left to right.
Left to right. So it goes like this?
Yeah.
And there is slight growth. He says it grows really slow. It does grow, and you can probably see from there to there, it grew just a little bit. But then he says it goes in a J shape. And he's right. And sometimes it grows awfully fast, and sometimes not so fast. But yeah, he's right. This is exponential growth. Okay? So that's growth. What's decay?
The opposite.
Well, wait a minute. The opposite could come
It's like
from...
a hook, maybe, like that. Like flip the your line across the x-axis.
This way?
Yeah.
That way?
Yeah.
Okay.
So
Is he right?
Yes.
Is that decay?
maybe.
No, sorry. Good guess. You know what? If he would have told me, he said flip it over the x-axis, if he would have said flip it over the y-axis, he would have been right. Okay, watch this. This is decay. Decay starts high, and because there's so much of it, it's decaying, it actually shrinks really fast, and then in the end, guess what? There's nothing left. There's so little left that you really do get smaller, but you can hardly tell anymore. It kind of runs parallel to the x-axis this way. So this one is decay, where this one's what? Growth. Okay? So left to right is how you read it. Okay, now what, this word right here, exponential. Why is anything exponential? Because x is found in the what spot? Where's your x found? What spot is that on that problem?
X.
That's the exponent spot, isn't it? So if x is found in the exponent spot, it is called an exponential function. Now, why is it growth versus what? Versus decay. Tate.
What?
Tate.
Yeah.
Can I have the phone, or is it just something that's going to stay out forever?
Text my mom.
I know. I have my mom, too. She calls me every once in a while, too.
Yeah.
Okay. All right. Here's the deal. What makes it growth? What makes it decay? Help me out. Anybody know why it's growth? Okay, watch this. See that number right there? Let's make that number 10. What would make 10 grow? Multiply it by that number, but what's that number got to be? Say it louder. Greater than 1. Perfect. If b is greater than 1, you have what?
A positive exponent.
You have growth. You will have growth. Okay. If the b value, if we're going to decay, what's the b value going to be? Less than 1. So if the base is less than 1, but what? Greater than 0. I didn't mean to put the equal sign, sorry. I didn't mean that. If the base is between 0 and 1, you are going to decay. So this is growth when the base is greater than 1. This is decay when the base is between 0 and 1. Okay. This number in the front, A, they basically tell this in your notes. They just say this is the starting point. Okay, so this is your start point or your original number, whatever you want to start with. That's where that goes. Okay, here's my question. Did that ring a bell from 9th grade? Little bit, nothing at all. What? Kind of. I got a kind of and somewhat.
Wait, when did we do this?
You did it in ninth grade. You did all this in ninth grade. Okay.
I remember us doing J's and S's.
S's. Okay. Well, this is not an S. But this.
Was it?
Well, if you want to call it a J, I guess it is a J in a way. Okay. But here's the deal. You did it in ninth grade. We're going to do it again. So when we get done here, I think this should make a lot of sense to you. I think. This is just me laying the groundwork. Now let's start your notes. Okay. So let's go back here. And I know I read the goals up here. Scribble that out. Okay. Next up, we're actually going to take an exponential problem and we're going to graph it. Here's the problem we're working on right there. Y equals 4 to the x power. Who wants to make a quick stab in the dark? Well, let's say it this way. Who's going to make a good, educated guess? Is it growth or is it decay? Tate? That hand was up. No?
No.
Ready?
Growth.
Why growth?
Because I don't know if we said it already. It's positive.
You're right, it is growth, but the only reason it's growth is because
The exponent.
the base.
The base.
What's the base? The base is 4. If the base is greater than 1, you have growth. Your base is what? 4. A base bigger than 1, you're going to grow. Okay, so here we go. We're going to put these numbers in for x, and then we're going to get out numbers for y. So the first number we're putting in is what? Negative 3. 4 to the negative third is what? Take your base. This is from chapter 6 now. Take your base, 4. Flip it. Give me the reciprocal, and then raise it to the what power?
12.
Third. What's 1 over 4 to the third?
64.
64. 1/64. Got it. Okay, fill it in, guys. Fill it in. Don't wait for me. Four to the negative 2. 1/16. Got it. Okay, 4 to the negative 1. 1 over 4 to the first, which is 1/4. Any number raised to the 0 power is?
Undefined.
No.
Not decay. Base.
1.
1.
Any number raised to the 0 power is 1. 4 to the first. 4 to the second. 16. Okay. So how do you graph exponential decay and growth? With a table. Once you make the table, graph the points over there, and you're going to get this. Negative 3, 1/64. Negative 2, 1/16. Negative 1, 1/4. Negative or 0, you get 1. Do you see the growth already? I mean, it's visible, right? It's there. All right, if I try 1, when I let x be 1, I get 4. 1, 4. Look at that. That is big, big time growth. A base of 4 is huge growth. Okay, if I try 2, I get 16. 16 would be somewhere up here. I'd say about right there. 2 goes in, 16 comes out. Here goes my graph, right through it. Okay, so there's your graph. Here's my question. What's it do on the backside?
What do you mean?
On the backside, back here.
Oh, it just goes straight.
Straight.
Well, because the number's going to be so small that it's going to be basically on the x-axis.
Yeah, he says basically it's on the x-axis. Here's my next question. Does it ever go below the x-axis? No. Now, guys, I can prove it to you. What if I let x be negative 5? If I let x be negative 5, what's 4 to the negative 5? It's 1 over 4 to the 5, which is 1 over, help me.
3,124.
3,000 what?
125. 25, I think. I'm pretty sure. 20.
For some reason, I thought last hour they said 24.
Was it 4?
I don't know. You have to punch it.
I think it's
Here's the deal.
1, 2, 4.
Is this number still bigger than 0? Yeah, that number is still bigger than 0 by a hair, just a hair. So guys, as you move further and further and further out, your number just gets closer and closer to 0, but never touches 0. Does that make sense? Yeah? Okay. Now, there's one more thing they're going to ask you in your assignment. Here's what they're going to ask. They're going to ask you this question. They want to know this. I don't believe you and I have talked about this all year, have we? What's an asymptote? An asymptote is this. Whatever your graph gets very, very close to. As you continue your graph, you approach a number, but you never touch that number. What's the number I'm never going to touch?
0.
0. So what we say is, we will never touch this line right here. What's this line?
X-axis.
It's the x-axis. But the equation for the x-axis is,
X equals 0.
no,
Y equals 0.
it's y equals 0.
Y equals X.
Because if you think about it, every point on the x-axis, what's the y value? 0. So every point on the x-axis, it's y equals 0. So this is your asymptote, and this is what they're going to ask you in your assignment. They're going to say, graph it, use a table, go ahead and graph it. What's the asymptote? And they're going to say this, what's the domain? Which I hope we all know it's the x values. What's the range? Hopefully we all know the range is the what value?
Y's.
Y's. Okay, what x values actually got answers?
To all of them.
So you're telling me way back here 10 gets an answer?
I mean, eventually, yeah.
Eventually, yeah, because 4 to the 10th is a number. It's huge, but yeah, it's going to eventually get it. So it would be all real numbers. All what x's work. Every x works. Now the range is what comes out of this function. Well, the only y values coming out are that one, that one, that one, until you get to what?
0.
0. Basically, this answer gets that y value. So all y values have to be what compared to 0?
Later.
How about equal to 0?
No.
Nope, it will never touch the x-axis. That's called the asymptote. Now look at what I did, because every one of your graphs will need this. A table, a graph, the domain, the range, and the asymptote. Are you okay? Okay. Okay, next page, I guess. Right there? Okay, this is the table I wanted to read to you. That's why I crossed out the other table. All right. This function right here, for the function y equals a times b to the x. Okay, for that function, that is called the exponential function. How do we know it's called the exponential function? Because we find x in what position? Where do we find x? In the exponent position. So if it's in that position, we call it exponential. All right. How do we know if it's growth or how do we know if it's decay? Well, it will be exponential growth when the base is what?
Less or greater.
Yes. So if this is greater than 1, we know we have what? Growth. Okay. How do we know if we have decay? Because the base is between what two numbers? Yeah. If the base is less than 1, but greater than 0, you have decay. Okay? I kind of already told you all this, so I hope that made sense. Yeah?
Wait, so if the base is over than 1 is the thing that I said that reflects over the y-axis, is that what that is?
say that again, if the base is over 1,
Yeah.
if the
Like,
base
you
is
know,
bigger
you
than
know,
1,
At the beginning, I told you to like reflect off the x-axis.
oh, that only happens when the A value is negative, you can reflect it over the x-axis. Okay. I'm not going to do any of that, by the way.
Okay.
All right. Now, here's a quick shot. This is a quick shot at how do you find domain, how do you find the range, how do you find the asymptote, and they actually talk about the y-intercept, which I did not talk about. Okay, in either case, look over there. Doesn't matter if it's growth or decay. In either case, the y-intercept is always going to be 0, comma what? It says 0, comma a. So guys, if you ever want the y-intercept, just take that number and just say 0, comma a. That's the y-intercept every time. Okay, what do we say about the domain? The domain will always be what? All real numbers. You guys, you can't go wrong. Just say all real numbers. It's always all real numbers. What about the asymptote? The asymptote will always be what? Y equals 0, because you always ride the x-axis. And the range will always be what? All y values greater than 0. Okay? Now, if I did all that with you, and then I just read it to you, so hopefully this time when I read that to you, you're kind of agreeing with what I'm saying. If not, keep looking back at the previous picture. Okay, these 4 problems, 1, 2, 3, 4, just tell me, are they growth or are they decay? G for growth, D for decay. I'll give you 10 seconds. Go. Ethan, first one, growth or decay? He says growth. How come? What's bigger than 1? The base. Which one's the base? 5. Look, right here. Base is bigger than 1. It's growth. Next one. Bryce, what is it?
No growth.
No growth? So you're saying decay?
Yeah, decay.
He says decay. How come, Bryce?
Because it fraction.
Fraction.
It's
The 1
less than
half.
1.
It's less than 1. Is he right?
No.
What?
Is this the base
No.
or is this the base?
No.
Yeah. The number with the x power is the base. Okay, this is the base. You have to say what? It's bigger than 1. It's growth. What about this one?
I was just confused.
Yeah, look at the base. 1/3 to the x. This one's decay. And this one's what? Decay, because of the 0.25 is less than 1. So it was GG, DD. That's it. Good? We don't care, hey, we don't care about the number in front of the base. That means nothing to us. Okay? Continue. All right, ready? Here's your function right there. Y equals, I'll write it again. Y equals 3 times 4 to the x. Is an example of exponential growth or decay? Growth, because why? Base is 4. Good. 4 is bigger than 1. Okay. Now, what is the y-intercept? Well, guys, if you don't want to read what I just read to you up there, you must think this way. The y-intercept is always going to be 0, comma something, right? Isn't that what the y-intercept is? On the y-axis, 0 something? Yes.
I think you got it.
What is it?
Is it 1?
He says 0, 1.
Because you said everything to the 4th, or to the power of 0 is 1, right?
Yes, I did.
That's
Is he right?
That's my reasoning, I guess. I don't know.
Is he right? Let's try it. 0 goes into x. 4 to the 0 is 1, Brady. You're right. But Brady, it says times 3. 0, 3. It's just the A value. Hey, guys, if you go up above and you read again, it says the y-intercept is always going to be 0, comma a. It's whatever the A value is. That's the starting point. This is what is known as the original amount. Okay? Do the next one. Any guesses on growth or decay? 0.7 is less than 1. So it's what? Decay. Okay. That y-intercept is 0 goes in. What's the answer? It's 1. So you're saying 0.7 to the 0 is 1, but I thought it was the A value. 1 is the A value. Guys, you know what they didn't do? They never wrapped it in parentheses, and they never showed you the number out in front. It is 1 out in front. You could have wrote it like this and took the 1 out in front and said 0, 1. Okay? This is kind of a tricky one because the A value wasn't visible. Okay? All right.
That's not right.
This one is right.
Oh.
Brady, can I just look? You put 0 into this one. 4 to the 0 is 1 times 3. It's 3. Put 0 into this one. 0.7 to the 0. 1. 1 times 1. 1. It works.
There's no zeros to multiply. So what makes that 1? I don't follow.
You're not following because you don't know the rule of this.
Are you sure? Maybe that's an oxymoron.
Hey, Brady, if you got a good question, I'll answer it. But otherwise, let's just talk here. Any number to the 0 power is 1. Any number. Doesn't matter. If I went like this, 3 to the 0, answer's 1. If I went like this, negative 3 to the 0, answer's 1. What's this? What's that? Isn't that negative 1? Yeah, because this is 1 with a negative in front. Now it becomes negative 1, but you got to be careful when you have that kind of problem. Okay. Brady, I tried to show you when I went over those properties. When I went over those properties, I showed you why it's always 1. Okay? You might not have been here that day. Okay. Next up. Now you go into story problems. When you go into story problems, take a look at this. This is what they want you to use on every story problem. I'll try to write it a little bigger for you. A of t. First of all, A is the amount, I always say the amount in your account, because sometimes we talk money, or it could be the value of what you're talking about. So it's the amount after how many time periods? T time periods. What's a time period? Could be a month, could be a year, could be a week, could be a day. Whatever they tell you. Equals A. What's A? The initial amount times 1 plus what?
1.
It says R, doesn't it? So R is the growth. It says here rate of growth. So if you're growing by 2%, 4%, 6%. And then it says raise it to the T power. What's T? Number of time periods. Now guys, I'm telling you time periods can change on you. Could be years, months, days, weeks, seconds, who knows. Okay. See that? Write that down and write this word underneath it. This is only for growth. So what do we use for decay? It's almost the same thing, but decay looks like this. Start with this number A, 1, not plus R, it's going to be 1 minus R to the T power equals A sub T. So there's two formulas. One formula says 1 plus R, that's growth. One formula says 1 minus R, that's decay. I didn't write that down. You should write it in your notes, okay? All right, here comes our first problem. Suppose you invest $500 in a savings account that pays how much? Yeah, tell me how to write that as a decimal.
0.035.
Yes. So 0.035 is 3.5%. Annual interest. Okay, first of all, annual interest, that means you're getting paid what? Once a year. That's what they're saying. How much will there be in your account after what? 5 years. So you must, first you gotta say to yourself, is this growth or is this decay? This is growth. You put money, you invested money, you're hoping to gain 3%, 3.5%. This is growth. So what you guys should do is this. A times 1 plus r to the t power. And then back here, you should say, what's the amount in my account after t years go by? If I'm you, I'm going to write the formula so I get it in my head. I want to stick it in my head and never lose it. Okay, this number right here, what's A?
500.
It's the initial amount. You invest 500. The interest rate you're earning is 0.035. How many years? 5 time periods. Each time period is a year. That's what they're telling you. Now, if I'm you, I might shorten this up for my calculator and I'd go like this. 1 plus 0.035 is? Yeah, this is what I would do if I were punching this into my calculator. So the amount in my account after 5 years is, I don't know. I'm waiting for you.
Wait, do you have to do the exponents first?
No, you just type this in. Your calculator knows. Your calculator will do exponents first, multiplication last. Just type it in. Don't do it piece by piece. If you're going to do it piece by piece, it's slower. Cassie, what's the answer? 593 and what? 84 cents. Now guys, if you're going to take her answer, that's her doing the work, and you just taking her answer. Punch it in. If you can't get that answer, then you're doing something wrong. So what did my 500 bucks do for me? It earned me how much interest? 93 bucks. So I waited 5 years to get 93 extra dollars in my account. Okay? Good? Did everybody get that answer? If you didn't get that answer, then I don't know how to help you. So we're okay? All right, next up. Try that one. Just try getting it set up. Let's see what happens.
This is your last chapter of the year.
We're going to trickle into chapter 8 a little bit. Just a little. Trickle means maybe 3-4 sections, okay? A value is what? 500. You invest 500. This is the starting point. Times 1 plus your interest rate is what? Yeah, 0.035, okay. How many years? How many years did you leave in the bank?
X.
Yeah. When will the account contain that much money? You don't know the time period, but you want this money to grow to what?
650.
650. There you go. Now I could shorten this up. 650 equals this times this. Okay. Now let me tell you this. You have no way to do this problem. I have never taught you how to solve an equation when the variable is in the exponent spot. So really the only way you guys can get an answer is pretty much just what?
Yes.
Guess and check. There you go. Guess and check. Now what we know from the previous problem, we know 5 years in the bank turns that into $593. So what are you going to start with?
6.
6, 7, 8, 9, 10. Something bigger than 5 years. Start guessing. Throw an answer up. 7. Okay, 7 for T, comma, gets me what value? 7 years in the bank.
6. You wanted the answer?
Yeah, give me the answer. Just give it to me.
36.
636. You guys, we want 650. We're too short. We want more time. Throw something else in.
8.
8. Throw 8 in. What do you get? 658. Okay, too big. Guys, it's between 7 years and 8 years. Now we got to get kind of picky. 7.
7.7.
7? 7.7. What's that give you?
651.
What is it?
651.
651. A little too big. A little too big.
I'll go one down now at 640.
Okay. How about go right between 7.6 and 7.7? 7 point what?
6.5.
6.5. Do that one.
50.5.
We're really close, aren't we?
Mm-hmm.
We're a little too big. How about 7.64 years?
If you do points,
650.3.
Okay, 650.3. I'm 30 cents over.
no, that's for,
Oh, that's this one?
no, that's for point 3.
Okay.
0.63.
Oh, you saying this is 6.3? Okay, so we're a little over, maybe 6.2. I don't know.
That's 7.64.
Would you agree that this one or this one is pretty good for an answer?
Yeah.
Yeah? Yeah, it's kind of hard to, I mean, unless I really punched it with you guys, I wouldn't know. But the closer and closer you can get, the better your answer is. So let's say about 7.6 to 7.65.
I got one with a penny off.
Penny off. What's it in?
7.627.
7.627 years in the bank gives you 650 what?
0.01.
And a penny?
Yeah.
Okay. So Brady went to there's thousands to get that answer. So this would probably be the best answer, but I would take, well, that's probably too big. Probably that one, 6.3. What method do I call this? Just guess and check. Hey guys, I will teach you a way to get that answer in 10 seconds. But that doesn't come to the end of chapter 7. So in the beginning of chapter 7, we guess. At the end of chapter 7, we actually do something with our calculator, and you'll see. Okay. Come on down. All right. Now, you got to tell yourself, you got to ask yourself, is it growth or decay? The value of a $125,000 house, what's the word? What do you think it is? Decay or growth? Growth. That word grows tells me it's growth. All right, so it's going to be what? A times 1 plus r to the t power equals A. A is the amount of the house value. But what did the house start at? That would be A. Yeah, $125,000 house. Oh, that's what I bought it for? Okay. Times 1 plus r. What's the house appreciating at? 2.3%, which is what? Yeah, 0.023 for how many years? 14 years. If I'm you, I'm going to rewrite that as 125 times 1.023 to the 14th. That's how I would punch it in if I were you. What's it going to be worth, the house?
171, 857, 166.
So your house which you bought 14 years ago, for 125 is now worth 171,000. Okay. So did you make money off your house?
Yeah.
Yeah, you made money off your house. And by the way, when you bought your house at 125, in 14 years, you don't owe 125. You probably only owe about 70,000 on it. Well, if you owe 70 and you made that much, truthfully, guys, you made $100,000. That's how homes work. You buy a house to gain what they call equity. Equity is money back in your pocket. Yes, sir.
What was it furnished?
No, Brady, people don't sell their homes furnished. Maybe some do, but very few. Too bad, Brady. You gotta buy your own furniture.
I figured how it worked. I've never bought a home before. I'm sure you have.
Okay. Go for it. Next problem. Is it decay or is it growth? How do you know it's decaying?
Because it decreases.
Decreases, right here. This gives it away. So here it goes. A times. Inside it's 1 minus r to the t power. This time it's minus r. What's the value of your motorcycle? $25,000. What are you losing each year? 18%. To write 18%, oh, right there. 3 years? Sorry. Anybody got this answer?
23.
13,000 what?
700.
700 something. Nobody has the rest of it?
80 for the top.
Something like that. Greg Doctor, smarter balance.
Jordan Ryder,
Greg
Thomas
Doctor.
Shower, and Brianna Schumacher. Skylar Delta, Bruce Hutchinson, Katie King, Greg Woodson,
Yeah, I didn't think that it's 8, so I'll just
Jordan Ryder, Michael Shower, and Brianna Schumacher.
you can do this. A sub 3, and the 3, all it's doing is this. It's going in for this, which is what I ended up doing anyways. It's just a function. That's the function that the value of your account after 3 years is, put the 3 in for 2. Work it out. It's whatever. You didn't get it either. 7,000. I had it last time. She's
With
gonna
the
type
following
this in.
students, please report to the office. Skylar Delgard, Bruce Hutchinson, Katie King, Riley Peterson, Jordan Ryder, Michael
$13,784.
Shower, and Brianna Schumacher. Thank you.
There it
How
is.
do you get 8.18?
Oh, well, 1 take away 0.18.
Oh.
Just if you subtract it, you get the 0.18.
That would explain a lot.